Behold, the brightest planet in our sky, a beautiful beacon of mystery, a shimmering jewel in the heavens, and also basically a pressure cooker that wants to kill you in about 3 seconds. It's Venus. Let's explore this. Hello there, welcome back to Star Stuff, where I really hope you're all doing well. Genuinely. Let's learn some stuff. Venus is often called Earth's twin, which is flattering, until you realize it's more like your twin who chose violence. Same size, similar gravity, completely unlivable nightmare also. Venus is so bright it's known as the morning star or evening star. Not because it's a star, but because it refuses to be ignored. That brightness comes from thick clouds made mostly of sulfuric acid. Yes, acid in the clouds. So if you're planning a romantic getaway in Venus, cancel it immediately. Let's check the weather on Venus. Temperature, about 465 degrees Celsius. I don't even have to tell you what that is in Fahrenheit. The pressure is about 90 times that of Earth, which is like being in very deep water. The atmosphere is thick, toxic, and aggressively unfriendly. This is thanks to a runaway greenhouse effect, where Venus basically said, what if we turn the thermostat all the way up forever? Fun fact, Venus is actually hotter than Mercury, because Mercury doesn't have an atmosphere to trap heat. Venus does, and it commits. Venus is the rebel of the solar system. It spins backwards, which is called retrograde rotation. Okay, listen. Most planets, including Earth, spin in the same direction when orbiting the sun. Venus is like, no thanks. Earth spins west to east. Venus spins east to west. So Venus takes 243 Earth days to spin once on its axis. And it takes 225 Earth days to revolve around the sun. So it's revolving faster than it's rotating. So Venus completes a full trip around the sun before it's even done with its first day. Imagine you start your day, and before the day ends, you're already celebrating New Year's Eve. That's Venus. So somewhere out there, the Venus calendar is having a breakdown. The backward spin also means the sun rises in the west and sets in the east. So here's where Venus stops being chaotic and becomes a scientific legend. At certain times, Venus appears between the Earth and the Sun, moving as a tiny black dot. This is called the transit of Venus. Back in the 1700s and 1800s, astronomers used to watch this happen from different locations. Here's the genius part. From different places on Earth, Venus appeared to take different paths across the Sun. That tiny shift, called parallax, allowed scientists to use geometry to help calculate the distance between Earth and the Sun. For the first time ever, we measured the scale of the solar system. Not guessed, measured. This is why this matters. If Venus were just a nearby light hovering above a flat Earth, it wouldn't cross the sun like that. It wouldn't appear differently from different locations, and you definitely couldn't use it to calculate distances millions of kilometers away. But it does. Perfectly. Which means this isn't an illusion. It's geometry working on a cosmic scale. Let's bring up some more points. Number 1, the phases of Venus. Observed by Galileo, Venus shows phases, like the moon, crescent to half to full. That only works if Venus is orbiting the sun. Flat Earth models don't predict this correctly. Venus brought visual evidence. Others brought confidence. Number 2, the brightness changes. Venus gets brighter and dimmer over time. Why? Because its distance from the Earth changes as it orbits the sun. The closer it is, the bigger and brighter the crescent. The farther it is, the smaller, dimmer the full phase. If it were just hovering nearby, it wouldn't behave like that. Number 3, predictable motion. Using the laws of Newton and Einstein, we can predict Venus's position precisely, years in advance. Flat Earth explanations struggle to explain where it'll be next Tuesday. Number 4, we've literally been there. The Venera program sent probes to Venus. They measured surface temperature, pressure, atmospheric composition. They even sent back images before being completely destroyed by the environment. That's not theory. That's direct measurement. So Venus is a warning about runaway greenhouse effects, fascinating extreme world, and an accidental destroyer of bad arguments, because it behaves exactly the way a real planet in a heliocentric solar system should. So next time you see Venus shining up there, just remember, it didn't show up just to look pretty. It helped us measure the solar system, prove how planets move, and quietly win arguments without saying a word. Thank you so much for watching, for all the support. If you enjoyed this video, please don't forget to like and subscribe. I make these short, easy explainers so that sharing it with someone is an easy task and they might actually watch it. Cool beans.